Good day, future CPAs! In today's discussion, we're going to discuss discounted cash flow valuation. The learning objectives are: first, determine the future and present value of investment with multiple cash flows. Second, explain how loan payments are calculated and how to find the interest rate on a loan. Third, describe how loans are amortized or paid off. And lastly, show how interest rates are quoted and misquoted. So let's start with explaining the core concept of discounted cash flow valuation. Discounted cash flow or DCF helps determine the value of an investment based on its future cash flows. Yung DCF, inaalam nito kung magkano yung value ng isang investment today based on sa projections na kung magkano yung pera na ma-generate nito in the future. So for us to better understand what is DCF valuation, let's have an illustration. Let's say na umutang sa iyo yung friend mo today ng 100k and ibabalik niya sa iyo yung pera, same amount, 100k 5 years from now. It is guaranteed na maibabalik niya yung utang niya sa iyo, and the question is, will you agree or not? Kung ako yung tatanungin, no. Why? Dahil once na ibinigay ko na sa kanya yung 100,000, ang tagal nang iintayin ko to receive the same amount, nawawala sa akin yung opportunity na maaari ko sanang gawin dun sa 100,000. Pwede ko sana ipang-invest o ipang-bili ng asset that will generate cash years from now. So maraming opportunities ang nawawala sa akin sa pag-iintay, and that is valuable to me. These are what you call opportunity cost, or the cost that you are paying in terms of an opportunity forgone. So hindi lang siya 100,000. It is 100,000 plus the added value of that 100,000 that could have been brought to me while waiting for my money to come in. So meron siyang monetary value, and in this illustration, let's say 20,000. So if my friend will offer me 120,000 or more instead of 100,000, then I might agree because he will not just compensate me for 100,000 but also dun sa valuable opportunities na nawala sa akin while waiting na mabalik sa akin yung pera. So if my friend will just give me 100,000 5 years from now, it is not equivalent dun sa 100,000 ko today, because a peso today is worth more than a peso tomorrow. That is the time value of money. So what my friend is actually offering me is 80k in today's term. This is the core idea of the discounted cash flow valuation. It is when someone is offering some amount in the future that is less valuable to you today. Discounted means it is less than the actual value. This DCF valuation is important, especially in making investing decisions. When the calculated DCF is above the current cost of the investment, the opportunity could result in positive returns. So moving on, let's now explain how to determine the future value of multiple cash flows. Let's begin with future value with multiple cash flows. We will use a timeline para mas maintindihan natin yung mga problems. So what does a timeline help us to identify? A timeline helps us visually see the three characteristics of cash flows: the size of the cash flow or the actual amount, the timing of the cash flow, so when does the cash flow occur, 1 year from now, 2 years from now, etc. And lastly, the riskiness of the cash flows, which is included in our relevant interest rate, which is used as our discount rate. There are two ways to determine the future value of multiple cash flows. One, by compounding the accumulated balance forward 1 year at a time, or by calculating the future value of each cash flow first and then add them up. Either of the two, we can still get the same answer. To illustrate the two different ways of calculating future values, consider the future value of $2,000 invested at the end of each of the next 5 years. The current balance is 0 and the rate is 10%. So now, let's calculate using the first technique, which is compounding forward one period at a time. We will make a timeline and label it to 0, 1, 2, 3, 4, and 5. In year 0, ito yung today or current period. Wala ka pang current balance, so it is 0 times 10% or 1.1, that is 0. Now we made a deposit of 2,000 at the end of year 1. So in year 1, you have 2,000. This 2,000 will earn interest of 10%. That is times 1.1. So it's gonna be 2,200. in year 2. And in year 2, you added 2,000. So in year 2, you have 4,200. And this 4,200 will earn 10% interest, that is 1 point times 1.1. So it will be 4,620 plus 2,000 deposit in year 3, that will be 6,620 times 1.1, that will be 7,282 plus 2,000 na deposit mo ng year 4, that will be 9,282 times 1.1 again, that will be 10,210.20 plus 2,000, that will be 12,210.20. So that's the future value. So next technique, same problem pa rin, pero this time, we will compound each cash flow separately. So this 2,000 in year 1, ito times natin siya sa 1.1 raised to 4. Bakit raised to 4? Kasi it will earn interest for 1, 2, 3, 4 period. And it will be 2,928.20. This 2,000 in year 2, ito times natin sa 1.1 raised to 3. Bakit raised to 3? Kasi it will earn interest for 3 periods. And that will be 2,662. This 2,000 in year 3, it will grow interest for 2 periods. Ayan, 1, 2. So, times 1.1 raised to 2, that will be 2,420. And this 2,000 in year 4, it will grow interest for only 1 period. So, times 1.1 lang, that will be 2,200. And in year 5, 2,000 lang kasi it will not earn any interest. So, i-add lang natin itong lahat and the total is 12,210.20. So, same answer katulad nung kanina. Next, present value with multiple cash flows. Suppose you need 1,000 in 1 year and 2,000 more in 2 years. If you can earn 9% on your money, how much do you have to put up today to exactly cover these amounts in the future? In other words, what is the present value of 2 cash flows at 9%? Let's draw a timeline. In year 1, you need 1,000 and in year 2, you need 2,000. And you can invest today the money at 9%. So how much money you need to invest today so you can take out 1,000 in year 1 and 2,000 in year 2. So we need to know the present value of 1,000 and 2,000. And in 1,000, ang gagawin lang natin is i-divide lang natin siya sa 1.09 dahil 9% yung interest rate. And that is 917.43. Yung 2,000 naman, i-divide natin siya sa 1.09 raised to 2 because we're gonna need money 2 years from now. You're gonna need this money 2 years from now, so that will be 1,683.36. So add them up, you will have $2,600.79. So that is the amount you have to put up today. So if you want to check if the answer is right, here is the checking. So today, you're gonna put away 2,600.79. This will grow at 9%, so after a year, you're gonna have 2,834.86, and you're gonna withdraw year 1, 1,000, so the balance when you start year 2 is 1,834.86. This money will grow at 9% or times 1.09, you'll have 2,000, and you're gonna take out 2,000, so the answer is 0. So we can see that after 2,000 is paid out in 2 years, there is no money left. Katulad dun sa future values, meron din tayong 2 ways to determine the present value of multiple cash flows. 1. By calculating the present values individually and add them up, or by discounting back 1 period at a time. To illustrate, suppose we had an investment that was going to pay $1,000 at the end of every year for the next 5 years. Discount rate is 6%. So let's have a timeline. We had an investment year 1, year 2, year 3, year 4, year 5. It's gonna give us 1,000, 1,000, 1,000, 1,000, and 1,000. To find the present value, we could discount each 1,000 back to the present separately and then add them up. So start tayo dun sa year 5. We will discount the 1,000 at 1.06 dahil 6% yung nakalagay na discount rate. So 1,000 divided by 1.06 raised to 5 because it is discounted for 5 periods. That is 747.26. In year 4, the 1,000 is gonna be discounted for 4 periods. So 1,000 divided by 1.06 raised to 4, that's gonna be 792.09. In year 3, 1,000 divided by 1.06 raised to 3 is 839.62. Year 2, 1,000 divided by 1.06 raised to 2, that is 890. Year 1, 1,000 divided by 1.06, that is 943.40. We will add them up and we will get 4,212.37. Another way to determine the present value is by discounting back one period at a time. This technique is time-consuming, but here's how it works. So take a look in year 5. We discount this 1,000 one period, so 1,000 divided by 1.06, that is 943.40. So we add the 1,000 we have in year 4, so we can have 1,943.40. Divide this amount by 1.06, that is 1,833.40, plus the 1,000 in year 3, so that is 2,833.40. Then divide it by 1.06, that is 2,673.01, plus 1,000 in year 2, that is 3,673.01. Divide it again by 1.06, so that will be 3,465.11, plus 1,000 in year 1, so we can have 4,465.11 divided by 1.06, that is 4,212.37. So, same answer din. A note about cash flow timing. Cash flow timing is very important in working present and future value problems. Sa halos lahat ng calculations, we assume that the cash flows occur at the end of each period, unless it is explicitly told otherwise. To illustrate, suppose you are told that a 3-year investment has a first-year cash flow of 100, a second-year cash flow of 200, and a third-year cash flow of 300. You are asked to draw a timeline. Without further information, you should always assume that the timeline looks like this. 1 year from today, you will get the 100, 2 years from today, you'll get the 200, and 3 years from today, you'll get the 300. So notice at year 0 or today, there is nothing. So notice that the first cash flow occurs at the end of the first period, the second at the end of the second period, and the third at the end of the third period. Our next topic will be all about valuing level cash flows, annuities, and perpetuities. So first, ano nga bang annuities and perpetuities? Annuities is a finite series of equal payments that occur at regular intervals. Take note, kapag ang first payment ay nangyari at the end of the period, ito ay tinatawag na ordinary annuity. Kapag naman ang first payment ay nangyari at the beginning of the period, ito naman ay tinatawag na annuity due. On the other hand, perpetuities are annuities that has infinite series of equal payments. Next, present value of annuity cash flows. So, sa pag-compute ng present value for annuity cash flows, we can use the process used in computing present value for multiple cash flows a while ago. Kaya nga lang, kapag ka sinabing annuity, may mga cases na yung number of cash flows ay may kalakihan. Halimbawa, a typical home mortgage calls for monthly payments over 30 years, at may total ito na 360 payments. Kung mapapansin ninyo, masyadong mahaba ang magiging process kung gagamitin natin yung method kanina. Since magkakapareho lang din naman ang cash flows sa annuity, merong formula na maaaring gamitin as shortcut para makompute ang PV for annuity cash flows. Annuity present value equals C times the quantity of 1 minus present value factor all over R. C stands for cash amount, R stands for interest rate, rate of return, or discount rate per period, T stands for number of periods, and the quantity of 1 over quantity of 1 plus R raised to T is called the annuity present value factor na kung mapapansin nyo ay katulad ng present value factor na ginamit kanina. Now let's have an example for present value for annuity cash flows. After carefully going over your budget, you have determined you can afford to pay $632 per month toward a new sports car. You call up your local bank and find out that the going rate is 1% per month for 48 months. how much can you borrow? To determine how much you can borrow, kailangan natin computein yung present value ng $632 per month for 48 months at 1% per month. Yung loan payments are in ordinary annuity form, kaya ang present value factor ay annuity PV factor is equal to the quantity of 1 minus the present value factor all over R. So, substitute lang natin yung values, quantity of 1 minus quantity of 1 over 1.01 raised to 48 all over 0.01. So, our annuity PV factor will be 37.9740. So, meron na tayong PV factor. Pwede na natin ma-compute yung present value ng 48 payments of $632 each. PV equals $632 times yung PV factor na 37.9740, and we will get a total answer of $24,000. Therefore, $24,000 is what you can afford to borrow and repay. Next ay ang annuity tables. So kung medyo nagmamadali ka sa computation, the easier way is to look at the annuity table. Here you'll see the number of periods and interest rates. So for example, you are looking for 3 periods at 10%. You just need to look for the row corresponding to 3 periods and then find the column for 10%. The number you see at that intersection should be 2.4869. Next is finding the payment. In this case, let's say given na yung annuity present values, terms of payment at rate, pero hindi mo pa alam kung magkano ang babayaran mo per period. So, ang hahanapin ay yung cash amount na ibabayad per period. Suppose you wish to start up a new business that specializes in the latest of health food trends, frozen yak milk to produce and market your product. Lucky Doodle Dandy, you need to borrow $100,000 because it strikes you as unlikely that this particular fad will be long-lived. You propose to pay off the loan quickly by making 5 equal annual payments. If the interest rate is 18%, what will the payment be? In this problem, alam na natin yung present value ay $100,000. The interest rate is 18% and there are 5 years. The payments are all equal. So, ang kailangan natin hanapin is yung relevant annuity factor and so for the unknown cash flow. So, annuity present value na $100,000 equals C times the quantity of 1 minus PV factor all over R. Substitute lang natin yung values to get the PV factor and makukuha na natin na PV factor ay 0.4371 and to continue, C times quantity of 1 minus 0.4371 all over 0.18. At makukumpute natin ang annuity PV factor na 3.1272. Then, transpose lang natin yung C to the left side at yung $100,000 to the right side. Then, multiply natin yung $100,000 sa 3.1272 and we will get $31,978. Therefore, you'll make 5 payments of just under $32,000 each. Our next topic is about future value for annuities. So we talk about present value for annuities in our last topic. Like that, meron ding formula for future value factor for annuity. Annuity FV factor equals the quantity of future value factor minus 1 all over R. The term, the quantity of 1 plus R raised to T is called the annuity future value factor. So, para makita natin kung paano ginagamit ang formula, let's have an example. Suppose you plan to contribute $2,000 every year to a retirement account paying 8%. If you retire in 30 years, how much will you have? The number of years here, T, is 30, and the interest rate, R, is 8%. So, we can calculate the annuity future value factor as annuity FV factor is equal to the quantity of future value factor, which is 1.08 raised to 30 minus 1 all over 0.08. So the quantity 10.0627 minus 1 all over 0.08 and we will get 113.2832. So to compute for FV, this 30-year $2,000 annuity is annuity future value is equals to $2,000 times 113.28, and we will get a total of $226,566. A note about annuities due. So sa previous discussion natin, ang natakal pa lang natin ay about sa ordinary annuities. Tulad ng sinabi ko kanina, yung ordinary annuity, the cash flows occurs at the end of each period. As for annuity due, the cash flow starts at the start of each period. Isa sa magandang halimbawa ng annuity due ang lease payments dahil ang lease payments are usually due immediately, so binabayaran siya at the start of each period. So para makita nyo yung difference ng ordinary annuity at annuity due, let's have an example. Suppose an annuity due has 5 payments of $400 each, and the relevant discount rate is 10%. The timeline looks like this. As you can see, nag-start yung timeline sa 0, unlike sa ordinary annuity na nag-start at 1. The relationship between the value of an annuity due and an ordinary annuity is annuity due value equals ordinary annuity value times the quantity of 1 plus R. So dito, may 2 steps lang tayo na gagawin. The first one is to calculate the present or future value as though it were an ordinary annuity. And the second step is to multiply your answer by the quantity of 1 plus R. Next naman ay ang perpetuities. Ang perpetuities are basically annuities. Kaya lang siya tinawag na perpetuity dahil yung stream of cash flows are perpetual. Kagaya ng sabi natin kanina, meron siyang infinite series of equal payments. Perpetuities are also called consoles, particularly in Canada and the United Kingdom. So may formula din when computing for perpetuities. PB for perpetuity is equals to C over R. For example, an investment offers a perpetual cash flow of $500 every year. The return you require on such an investment is 8%. What is the value of this investment? The value of this perpetuity is perpetuity PB is equals to $500 divided by 0.08, and we will get $6,250. Next, dito sa table, makikita natin yung summary, annuity and perpetuity calculations. As you can see, nakalagay sa table yung mga symbols as well as its meanings, at makikita rin sa table yung formulas na na-discuss natin kanina. So moving on to the next, the growing annuities and perpetuities. Annuities commonly have payments that grow over time. Suppose, for example, that we are looking at a lottery payout over a 20-year period. The first payment made 1 year from now will be $200,000. Every year thereafter, the payment will grow by 5%, so the payment in the second year will be $200,000 times 1.05 is equals to $210,000. The payment in third year will be $210,000 times 1.05 is equals to $220,500, and so on. What's the present value if the appropriate discount rate is 11%? If we use the symbol G to represent the growth rate, we can calculate the value of A growing annuity using a modified version of our regular annuity formula. Growing annuity present value is equal to C times the quantity of 1 minus the quantity of 1 plus G over 1 plus R quantity raised to T all over R minus G. So plugging in the numbers from our lottery example and letting G is equals to 0.05, we get PB is equals to $200,000 times the quantity of 1 minus the quantity of 1 plus 0.05 over 1 plus 0.11 quantity raised to 20 all over 0.11 minus 0.05 is equals to $200,000 times 11.18169. That will be $2,236,337.06. Meron din formula for the present value of a growing perpetuity. That is, growing perpetuity present value is equals to C times the quantity of 1 over R minus G or C over R minus G. In our lottery example, now suppose the payments continue forever. In this case, the present value is PV is equals to $200,000 times 1 over 0.11 minus 0.05. So PV is equals to $200,000 times 16.6667, and we will get a total of $3,333,333.33. The notion of a growing perpetuity may seem a little odd because the payments get bigger every period forever. But, as we will see in a later chapter, growing perpetuities play a key role in our analysis of stock prices. So moving on, comparing rates, the effect of compounding. The next issue we need to discuss has to do with the way interest rates are quoted. This subject causes a fair amount of confusion because rates are quoted in many different ways. Sometimes the way a rate is quoted is the result of tradition, and sometimes is the result of legislation. Unfortunately, at times, rates are quoted in deliberately deceptive ways to mislead borrowers and investors. To know why, we will discuss these topics in this section. Effective annual rates and compounding. Stated interest rate. The interest rate expressed in terms of the interest payment made each period, it is also known as the quoted interest rate. Effective annual rate, or EAR. The interest rate expressed as if it were compounded once per year. We provided examples and additional information that we get from the book to fully understand this topic. So, calculating and comparing effective annual rates. In this topic, we will explain how to compute effective annual rates. Bank A, 15% compounded daily. Bank B, 15.5% compounded quarterly. Bank C, 16% compounded annually. To compute the following, we need to familiarize ourselves to this equation. EAR is equals to the quantity of 1 plus quantity quoted rate over M quantity raised to M minus 1. Bank A, 15% compounded daily. We let EAR is equals to 1 plus the quantity 0.15 over 365 quantity raised to 365 minus 1. EAR is equals to 0.16179. We will convert the decimal to percent, and our final answer for Bank A is 16.18%. We converted the 15% into decimal and we placed it to the quoted rate. On the other hand, we placed 365 to the M because M represents the number of compounding periods. Our compounding period in Bank A is daily, and we have 365 days in a year. Bank B, 15.5% compounded quarterly. We let EAR is equals to the quantity of 1 plus quantity of 0.155 over 4 quantity raised to 4 minus 1. So that is 0.16424 or 16.42%. We just repeated the steps on how to calculate the EAR. The only difference that we had made is the number of compounding periods. On Bank A, it is stated that they have compounding periods daily, while on Bank B, they quarterly compounding per year. 16% compounded annually. EAR is equals to the quantity of 1 plus quantity 0.16 over 1, quantity raised to 1 over minus 1, or 0.16 or 16%. The importance of the effective annual interest rate is that it allows us to evaluate the true return on an investment or true interest rate on a loan. To explain it as simple as we can all understand, effective interest rate is important in figuring out the best loan or determining which investment offers the highest rate of return. To continue about the discussion about the Bank A, B, and C, Bank B is the best one if you are thinking of opening a saving account. Also, it's the best one to represent loan rates. EAR illustrates two things. First, the highest quoted rate is not necessarily the best. Like for our example, Bank C has the highest quoted rate, which is 16% compounded annually, but the least one who has the EAR. Second, compounded during the year can lead to a significant difference between the quoted rate and the effective rate. Remember, effective rate is what you actually get or what you pay. What's the EAR? A bank is offering 12% compounded quarterly. If you put $100 in an account, how much will you have at the end of 1 year? What's the EAR? How much will you have at the end of the 2 years? First, we need to determine the future value. The bank is effectively offering 12% over 4 is equals to 3% every quarter. If you invest $100 for 4 periods at 3% per period, the future value is FV is equals to P times the quantity of 1 plus R times T. So F is equals to $100 times the quantity of 1 plus 0.03 raised to 4. $100 times 1.1255, that is 112.55. On the other hand, we also need to determine the EAR. We're at $100 times the quantity of 1 plus 0.1255, it is equal to 112.55. Convert it to percent, that is 12.55%. Therefore, our EAR is equals to 12.55%. We also have two different ways to determine what we would have at the end of 2 years. One way is to recognize that 2 years is the same as 8 quarters. At 3% per quarter after 8 quarters, you would have $100 times 1.03 raised to 8, that is $126.68. The $100 is the one you will put into your account, and the 1.08 came out from the interest per quarter, and the 8 came from the total of quarters in 2 years because 1 year has 4 quarters and we have 2 years in our given, so that the quarters sum at 8. Second, we could determine the value after 2 years by using an EAR of 12.55%. So after 2 years, you would have $100 times 1.1255 raised to 2, that is $126.68. Thus, the two calculations produce the same answer. This illustrates an important point. Anytime we do a present or future value calculation, the rate we use must be an actual or effective rate. In this case, the actual rate is 3% per quarter. The effective annual rate is 12.55%. It doesn't matter which one we use once we know the EAR. Quoting a rate. As a lender, you know you want to actually earn 18% on a particular loan. You want to quote a rate that features monthly compounding. What rate do you quote? In this case, we know the EAR is 18%. We know this is the result of monthly compounding. Let Q stand for the quoted rate. We thus have EAR is equals to the quantity of 1 plus quantity quoted rate over M quantity raised to M minus 1. So that will be 0.18 is equals to the quantity of 1 plus the quantity of Q over 12 quantity raised to 12 minus 1. So 1.18 is equals to the quantity of 1 plus the quantity of Q over 12 quantity raised to 12. We just transferred the negative 1 to 0.18 to have our EAR. We need to solve this equation for the quoted rate. This calculation is the same as the ones we did to find an unknown interest rate in Chapter 5. 1.18 raised to the quantity of 1 over 12 is equals to 1 plus the quantity of Q over 12. 1.18 raised to 0.08333 is equals to 1 plus the quantity of Q over 12. 1.0139 is equals to 1 plus the quantity of Q over 12. Q is equals to 0.139 times 12, that is 16.68%. Annual percentage rate, APR. The interest rate change per period multiplied by the number of periods per year. The confusion over APRs arises because lenders are required by the law to compute the APR in a particular way. By law, the APR is simply equal to the interest rate per period multiplied by the number of periods in a year. Example, if a bank is charging 1.2% per month on car loans, then the APR that must be reported is 1.2%. Times 12 is equals to 14.4%. For example, an APR of 12% on a loan calling for monthly payment is really 1% per month. The EAR on such a loan is thus, EAR is equals to the quantity of 1 plus quantity APR over 12, quantity raised to 12 minus 1. That is 12.6825%. What rate are you paying? Based on our discussion, an APR of 18% with monthly payment is really 0.18 over 12. That is 0.015 or 1.5% per month. The EAR is thus EAR is equals to the quantity of 1 plus the quantity of 0.18 over 12, quantity raised to 12 minus 1. That is equals to 19.56%. This is the rate you actually pay. Difference between APR and EAR. The main difference between APR and EAR is that APR is based on simple interest, while EAR takes compound interest into account. APR is most useful for evaluating mortgage and loans, while EAR is more effective for evaluating frequently compounding loans such as credit cards. Taking it to the limit, a note about continuous compounding. Table 6.3 illustrates the EARs do keep getting larger, but the difference gets very small. As the number in Table 6.3 seems to suggest, there is an upper limit to the EAR. If we let Q stand for the quoted rate, then as the number of times the interest rate is compounded gets extremely large, the EAR approaches EAR is equals to E raised to Q minus 1, where E is the number 2.71828, or look for a key labeled E raised to X on your calculator. For example, with our 10% rate, the highest possible EAR is 10.51709%. In this case, we say that the money is continuously or instantaneously compounded. Interest is being credited the instant it is earned, so the amount of interest grows continuously. So what's the law? At one time, commercial banks and saving and loan association SNLs were restricted in the interest rates they could offer on savings account. Under what was known as Regulation Q, SNL were allowed to pay out most 5.5% and banks were not allowed to pay more than 5.25%. The idea was to give the SNL a competitive advantage but didn't work. The law did not say how often these rates could be compounded. However, under Regulation Q then, what were the maximum allowed interest rate? The maximum allowed interest rates occurred with continuous or instantaneous compounding. For the commercial banks, 5.25% compounded continuously would be EAR is equals to E raised to 0.0525 minus 1. That is 5.39026% or 5.39%. So, dito naman tayo sa loan times and loan amortization. Ang unang loan type ay yung pure discount loan. The simplest form of a loan where the borrower receives money today and repays a single lump sum at some time in the future. These loans are very common and are repaid within a short period of time. An example, treasury bill. Ano nga ba ang pure discount loan? Ito yung nangutang ka ngayon and pag magbabayad ka is one at a time payment lang. Kasama na doon yung perang hiniram mo and yung interest. In short, single lump sum payment. So saan ba madalas ginagamit ang pure discount loan? Ito ay common sa government bonds, which is a way for the government to borrow money, and it's also known as T-bill or treasury bill. And ang duration ng loan is just a few months, so under the year. Let's proceed to the given problem. A T-bill promises to repay 20,000 pesos in 12 months. The market interest rate is 7%. How much will the bill sell for in the market? So we need to find how much will the bill sell for in the market. Ang hinahanap natin dito ay ang present value. Alam naman natin kung paano kunin ang PB, so PB is equals to 20k divided by 1 plus yung interest rate natin na 7% and imumultiply natin siya sa exponential na 1 kasi isang taon lang naman nila babayaran yung loan, and our present value would be 18,691,000 18,691.59. So that was the pure discount loan. Next one is interest-only loan. A loan where the borrower pays interest every period and repays the entire principal at some point in the future. It's more complicated than the first one. Ang pinakaiba ng interest-only loan sa pure discount loan ay hindi nito isang bagsakan na hindi ito isang bagsakan na bayaran pero nagbabayad siya regularly. The loan is common sa mga corporate bonds. For example, consider a 5-year interest-only loan with a 7% interest rate. The principal amount is 20,000 pesos. Interest paid annually. What would the stream of cash flow look like? Ang tanong is paano ang sistema ng pagbabayad nila ng interest simula sa unang taon hanggang sa 2nd, 3rd, 4th, and 5th year. Year 0 ay yung taon na nanghiram sila ng 20K and the rest of the year is yung pagbabayad nila ng interest regularly which is equivalent sa 1,400. And in the 5th year, bukod sa interest ay babayaran na rin nila yung principal na hiniram nila. So in the 5th year, di lang interest pati principal. So that is 1,400 plus 20,000. So 20,400 pesos. Amortized loan. The borrower pays some interest and principal every month, usually in the form of fixed payments. Examples, mortgages, car, loans, etc. Example, a business takes out a 5,000 pesos 5-year loan at 9% interest. The loan agreement calls for the borrower to pay the interest on the loan balance each year and to reduce the loan balance each year by 1,000. Because the loan amount declines by 1,000 each year, it is fully paid in 5 years. How does amortization table looks like? And now, yung nakikita nyo sa screen is the amortization schedule. So in this case, na yung total payment every year ay bumababa and ang reason nun is that the loan balance goes down resulting in a lower interest charge each year. Yung 1K na principal reduction is constant. So para makuha mo yung interest sa unang taon, i-multiply mo lang yung 5K na beginning balance sa interest per year na 9% na ang kalalabasan is 450. Ito yung interest sa unang taon. So, the total payment for the first year is 1,450. Yan yung pinagsamang principal na 1K plus yung interest na 450. And in the second year, the loan balance will be 4K or 4,000 na lang. So, ang interest dito is 4,000 times 9% is equals to 360. And ang total na babayaran nila for the second year is 1,360 pesos. And ganoon na lang din yung gagawin sa remaining years. So that will be the end of the discussion. Thank you and God bless us all.